Microphone check 1, 2. Let me know if y'all can hear me. Get my lighting up here. Episode number 115 of the LiveLabs. You are now tuned in to the network. The network. The network. And your boy got a new phone. So I'm able to hit the at will. But of course, that didn't get rid of those ads. Lighting, camera, action. Don't look like y'all can see me. Microphone check. All right. Got S Move in the building. Appreciate you for tuning in. I ain't see you in a minute. Jesus, man. This phone, man. It's sensitive. That's the one thing about it. We're going to do another OSPF lab. I know y'all like, damn, is this Groundhog Day? Didn't this guy do a OSPF lab in the past couple days here? Yes, I have, but y'all know what I say. Repetition is the key to mastery. We are going to do this lab right here, configuring, not that one. That's single area OSPF. We did that one already. We did that a couple episodes back. We're going to do this one right here. Y'all see all these check marks here that we've got so far? We're going to do that until we get to right about there. And then I should finish that series. So that's how far we are so far with the Boson NetSim, at least. I guess we about a quarter way through, right? Something like that. And then after that, we'll be doing some anarchy. This is the one, this is the lab, this is the actual exam I have to take. I don't have to take the encore, but y'all know I like going back to the fundamentals and stuff like that. So make sure that one is loaded up. That's the one I wanted to do. Planning and configuring multi-area OSPF. So I'm going to give y'all some time to tune in. Y'all know typically I stream Monday through Thursday, 8 p.m. Eastern Standard Time, but I'm going to change that schedule up, man. 9 o'clock seems to be a more ideal time for me. It gives me time to, relax after working and stuff. And if I have my daughter and stuff, even though I don't really have her during the week, but it gives me a little bit more time to at least get settled in and eat something, work out if I could. I typically work out early in the morning, but it seems like a better time. So I might change that. I might do Monday. I'm gonna try Monday through Thursday, but I want to try to keep Wednesdays because they just opened up the gym. Well, they didn't just open it up. I guess it's been open up. I want to start hitting those up. It's good to have your mental health. You need to have a good work-life balance. And not that this YouTube stuff feels like, not that this YouTube stuff is work for me, but it does feel like, it's starting to feel like work. So, it's a lot of time to get prepared for these, for these live streams and stuff like that. To make sure the equipment's up and running, up and running, making sure that I have what I'm going to cover, at least the concept down before trying to explain it and do it with you guys. Which, by the way, once I get to 5,000 subscribers, I'm going to be gifting away a copy of Boson NetSim. Y'all know they gave me a promotional copy to kind of use on my channel and stuff like that. But once I get to 5,000 subscribers, I'm going to gift away a copy. So that way we could do it together and stuff like that, right? So, like I said, I'm going to give it some time for some people to tune in to kind of get caught up with us. In the meantime, there was a article wanted to share with y'all. This Cisco router repair revives piece of internet history. Cisco router repair revives piece of internet history. These days, it would be fair to say that the internet as we know it runs on Cisco hardware. While you might never see them at work, there's an excellent chance that every web-bound packet leaving your computer or smartphone will spend at least a few milliseconds of its life traveling through hardware built by the San Jose, California-based company. Y'all know how much I'm a Cisco fanboy, but I like this article here. But of course, even a telecommunications giant like Cisco had to start somewhere. Cisco's first commercial router, the Advanced Gateway Server, was released in 1986 and helped put the company on the path towards unfathomable success. Say that 5 times in a row. So when an AGS popped up on the local classifieds, so Andreas Semmelman had wanted to add one of these microwave-sized machines to his collection for some time. Damn, y'all want to see the size of this? It's like pretty much Cisco's first router. This is it right here. I guess he found it in, this is like some kind of advertisement. I mean, not advertisement, kind of like kind of like a Craigslist or whatever. He found one of those, and then he opened it up basically and got it working. And this is pretty much internet history. This is like pretty much their first router right here. This huge size of a microwave, man. Can you imagine that? Can you imagine that, man? It's just like supercomputers. Supercomputers back in the day, remember, like in the 50s and stuff, used to take up a whole room. That's how large those computers are. So I guess the first router from Cisco. There's this one. While AGS was Cisco's first router, it wasn't its first product. So it was their first router, but it wasn't their first product. But anyways, the guy found one in the classifieds, basically fixed it up, and he's just showing it off, really. So when an AGS popped up in the local classifieds, he didn't hesitate to make the hour drive to go pick it up. But like many pieces of vintage computer equipment, it needed a little help getting back on its feet. Since he had to take the router apart anyway to diagnose what ailed it, Andreas decided to take photographs along the way and document this piece of internet history. Imagine finding one of those on eBay or something like that, man. I bet you they're probably on eBay, but they're probably going for like thousands of dollars just because it's just, like you said, internet history. He walks the reader through the massive processor, Ethernet, and serial cards that are housed in the unit's rack-like enclosure. We appreciate the time. We appreciate him taking the scenic route, as it gives us a great look inside what would have been the state-of-the-art telecommunications gear when this version of AGS hit the market in 1989. That's rather interesting, man. Considering this age, this piece of 1980s Cisco gear ended up being in relatively good shape, but that's not always the case. Over the years, we found ourselves in awe. So blah, blah, blah. He basically drove an hour to get it, and he has an old-ass router. So that's pretty cool. I thought that was a cool story there. CSB, right? Planning and configuring multi-area Ospf. I guess we'll just go ahead and get started. If you have a copy of Boson NetSim, you can do this along with me. It is this lab right here in the Encore section. So go to the Encore section, and we're going to be doing planning and configuring multi-area Ospf 1. I wanted to do 2 as well, but this one's pretty long. So they want us to kind of plan our network statements and our Ospf network. And then, you know what I want to do? I'm going to take a screenshot of this because y'all know I like to, let's make this float real quick. Float. Take a screenshot of that bad boy because I want to drag and drop any of this stuff, right? So that way, y'all know I like to do my annotations and stuff while we explain this. So right here, well, let's put it in. Y'all know my favorite high-tech application to draw network topologies, Microsoft Paint. Let's move this guy over. Make this a little bit bigger. There we go. That's what we're going to be working with, right? Let's get our brushes. Bloop, bloop. Make it a little thicker. Let's do it red. Start with that. What's the first thing they said they wanted us to do here? That's our topology. Let's float that back in there. Boom. Come on. Come on, man. I just saw it go in there. Oh, there we go. We just got to put it right next to it. All right, there we go. So we got some basic configuration or commands that we got to do to go into global config mode. Some basic show commands and stuff like that. Here's our IP addressing guide. Lab tasks. This task involves basic connectivity, so they just want a basic ping test on these guys. So we're gonna have right here on all routers verify the IP address and state of each interface, the line and protocol. So basically they want us to check layer 2, layer 3. Obviously layer 1 should be up. This is an application, right? On router 1, verify connectivity with branch backbone router 1, backbone router 2, router blah, 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 blah. So basically they want us from router 1 to ping this guy, ping that guy, ping this guy, ping that guy, and then ping that guy, right? So, and the respective addresses are right there, 172.30.1.1, blah, 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 blah. So let's go to router 1. Boop. He's right there. First address was ping. Let's move this over so we can see. Boom. Close that. Move this bad boy over. Got any questions so far or anything? I know we just got started and stuff. They just basically wanted to do some, oops. Oh, Jesus. Come on, man. Okay, that's a bad IP address, so then get out of it then. Let's do 1 and then get out. You can't control Z out of this either? What's going on here? Oh, the shit crashed. Don't crash on me, man. Boson, don't do me like that, man. We got to restart this. Oh, well. All right, let's restart. Let's restart. I was doing too much there. We go right there. I got two versions of it. Let's see what else we got on the agenda here while that bad boy is loading up. That's pretty cool though. See, Cisco AGS Plus. I want to see if they actually have those on eBay. Their first router. We're still loading up over there, right? IT news, biz. We're loading up. We loading up. What's going on here? What's going on here? Still loading up, I guess. Yeah, there it goes, right there. Taking a while over there, man. I don't know what's going on with this thing, man. Again, we're going to the Encore Lab, planning and configuring multi-area OSPF 1. I'm glad I took a copy of the topology here, so that way we get started. We'll use let's use black. All right, yeah, we'll do that. We'll do that. We already got the preview going. We already loaded this guy up, or what? What's going on? Are you loading up or what? Not that one. This one. Multi-area OSPF 1. Come on, buddy. Don't crash again, man. If this thing crashes again, then we're just going to end the stream, right? InfoSec researchers say Apple's bug bounty program needs work. Apple allegedly pays for less bugs than its competitors do and pays more slowly. But they make you pay more for their damn products. I swear, man. Like I can't believe I hate that the fact that the iPhone doesn't have the little jack to plug up your headphones if you wanted. We'll go back to that article in a second. Let's get this lab started here. Let's get this lab started. Let's move this bad boy over. Y'all seen the topology already? Y'all familiar with it already? At least I am. No, we wanted to go to router 1 and have him ping those other guys, right? Again, we're going to do this. We're going to have router 1 ping that guy, ping that guy, ping that guy, ping this guy, ping that guy, just for some basic connectivity, right? Ping, what were those addresses? 172.30.1.1. 172.30.1.1. That worked. I'm pretty sure they all work, right? 1.5 works. 10.0.0.2. Who else? 10.0.0.10. That worked. 10.0.0.6. That worked. So we got basic connectivity. All pings should be successful. Good. From router 2. So we're going to go to router 2. He's right over here, right? So router 2 is over here. From router 2, ping router 4's FA10 interface. The ping should be successful. So we're going to go from router 2 and ping FA10's interface. So we're going to go from router 2. We're going to ping that guy going this way, right? We're going to ping that fast Ethernet interface. He said that interface was 10.3.0.4. Enable ping 10.3.0.4. That was successful. Good to go. Task 2, plan for multi-area OSPF. Now, I kind of did a little quick run here, but they just want us to plan this here. Plan the stuff here. So maybe I should get a little, I guess we'll do this. No, we'll do this. Let's put we'll put our network statements there. We'll put our network statements right here because that's what they want us to do. This task involves planning the OSPF. Move this bad boy. Bloop. Planning the OSPF configuration. You will use the commands list here to implement OSPF in task 3. So this task 2, we're just going to do the planning part first. You will configure IP addresses on loopback interfaces to configure router IDs on all routers in this lab. Explain why it is important to perform this step prior to starting the OSPF configuration process on any of the routers. Well, for one, if we already have some existing IP addresses that are not loopbacks, right? Then the router will use those IP addresses as its router ID, depending on the highest IP address, right? If there's no loopback set up. But if we want our loopback IP addresses to be used as a router ID, then we had to make sure those are configured first before we implement OSPF, right? Because if we just, let's just say we go on router 1, right? Let's see what he got so far, right? We do a show IP interface brief, and we have this IP address, that IP address. We have all these IP addresses here, right? Well, the router is going to pick the highest IP address first and choose that as router ID. What's the highest IP address on here? We got 172.30.1.6, right? It's higher than this one, it's higher than that one, it's higher than that one, and higher than this one, right? So this will be his router ID. But it said here, you will configure IP addresses on loopback interfaces to configure the router IDs. We haven't done that yet, so once we configure those loopback addresses, and then we turn on OSPF, it's going to choose the loopback IP address, at the highest loopback IP address as its router ID. That's why it's important, right? So that was question 1. Y'all got that so far? And we've done that. I know we've discussed that a million times. We got Professor Black Ops in the building. Appreciate you for tuning in. Professor Black Ops, man, what's going on with T-Mobile, man? I have T-Mobile. I had to change my password. I mean, I know you've covered that data breach on your channel as well. If you guys don't know, Professor Black Ops covers a lot of cybersecurity stuff and hacking and all that kind of stuff in general, right? I have T-Mobile. They just had a data breach. The good thing that they're doing to kind of mitigate that problem is, so I just bought me a new T-Mobile phone last week, right? Because I needed to install some 2-form factor authentication stuff for work. They pre-installed, what was it? T-Mobile, or I'm sorry, McAfee antivirus scan on here. And I think it's free for like a year or something like that. So if you got T-Mobile, there's that. They're also asking you to change your passwords and kind of PIN numbers or anything like that, because all of that stuff has been, is floating around in the dark web somewhere. So they know about my my 3rd grade teacher's name and stuff like that, and my favorite pet or stuff like that, right? So, but yeah, that's just crazy, man. T-Mobile. Anyway, what was the next task here? Backbone router 1, backbone router 2, and router 1 should all be configured as members of the backbone, right? So again, backbone 1, 2, and router 1. So they want this guy, and this guy to be part of the B, right? The backbone, right? So that basically means they want these guys to be in area 0, right? Not this guy, not this guy, not this guy, not this guy, or this guy, right? They want all these guys right here, bloop, to be in the backbone, part of the backbone, which is also known as area 0, right? Or area 0, also known as the backbone. What did they say? Only router 1's serial 00 and 01 interfaces should be members of the backbone. So we got, it's probably going to be, yeah, so then that means it's this interface here and that interface there, because it's part of that backbone. That's backbone. This one is not going to be part of the backbone, right? So they're just wanting these guys right here to be part of the area 0. Nothing else, right? That's what they're saying here. Your configuration should be specific enough so that as additional networks are added to the router, those networks are not automatically advertised. So we need to have some really specific network statements because of this, right? Professor Backup said, I did 3 videos on T-Mobile in the last 12 months. Man, that's crazy, man. That's just crazy. Love my brothers for that, man. Jeez. Yes, man. T-Mobile, man. At first, when they initially disclosed this data breach, they just said, we have a breach, and we don't know exactly what was taken, but just make sure you take some preventative measures to protect yourself. And then might be like a day or two later, they were all like, yeah, okay, so even if you are a current T-Mobile customer, even past T-Mobile customers, even prospective T-Mobile customers has their data that's floating around somewhere in the dark web. And it's just crazy, man. We got here's to you 2 cents. Appreciate you for tuning in, man. Hit me with a bruh there. And it's just like more as more information was gathered, then they basically was like, okay, yeah, now you probably need to want to change your, tighten up on your security, change your passwords, change your PIN numbers. And it's just like, oh my gosh, now we really got to take some preventative measures, man. Because there's such thing as what's it called? SIM card hijacking, where if they can get information from your SIM card or at least your phone number, they can hijack it and just basically render your phone useless and have all of your information. So it's just crazy, man. That T-Mobile data breach is no bueno, man. How are their stocks doing, man? That's just crazy. Anyway, the IP routing tables on each router should be populated with the specific IP subnets in your network. Using the IP address table, list the specific networks and masks that should be configured so that only those specific interfaces run Ospf. So we'll start with router 1. They say router 1's serial 00 and 01 interface, which was the ones I circled, this guy and this guy. What are some network statements that are going to put those to participate in a backbone area, right? So we do show IP. Well, we already did that, right? So serial 00 and what was the other one you said? 01. So these two right here, we need some network statements that's going to catch them two right there. We'll go with, we also need to know the subnet mask, right? So y'all know my favorite command other than show IP interface brief, right? Show proto calls, if I can spell it right, calls. We got /30. So we, a good network statement that'll catch both of these will be 172.30.1.0 0003, right? So we're gonna say so for R1, we're gonna say 172.30.1.0 000.3, and they said put that in. Let me see. Area 1. No, those should be in area 1. So this should be part of the backbone. So that means it needs to be area 0. Duh, my bad. So those two needs to be in area 0, right? So this is area, let's do that, area 0, like that. So them two interfaces right there that I circled need to be in area 0. So another, this network statement should catch both of those guys, right? What else they want us to do here? That should be for router 1. They need us to come up with some network statements that's going to put this in the backbone area and this in the backbone area. So BB1 and BB2. We'll do that like that, right? And let's do this to be like, well, yeah, that's good. That's good. That's good. BB1. So we'll go to BB1, which is up here. Let's do a show so I can spell show protocols. Y'all hit me with that like button. Make sure you hit me with the Foster said, what happened to the router ID? Good question. So what happened here was we're doing the planning first. They don't want us to do any configuration first, right? Now, that's a good question. They want us to put some loopbacks. I guess they kind of did this stuff out of order, or not necessarily out of order, but they just kind of gave us the steps out of order. We should do the router IDs first, right? But the thing is, they want loopbacks to be the loopback, the IP addresses on the loopbacks to be router IDs, right? However, the loopbacks are not configured just yet. So we're going to configure the loopbacks and then do the routing process, OSPF process. So good question. In this case, backbone router 1, we have, this is his IP address. We need a network statement that's going to catch that and put it in area 0. That should be, I'd say 172.30.1.0 0003 should do that as well. So same thing. This same network statement should do that as well for backbone router 1. And then let's go to backbone router 2. Probably the same thing. Let's see what his interface is. So protocols. We got to be careful with this one, right? This says, what the heck's going on here? Let me look at that later. Sim hacking is real. Yeah, man, that is crazy, man. We got Peter Hunt in the building. Appreciate you for tuning in, guys. I'm gonna be man. Listen, man, what was going on here with this? Let me scoot this over and see what's going on here. FS1. Oh, probably some. Okay, we got some power issues there. We'll see. See 22. Oh, they probably set to another time. Interesting. Okay. All right. I know what's going on here. We need a network statement that's going to catch this. We got to be careful with this one. We're not going to say 1.0. This is in the 1.4 network. So we got to be careful with that one, right? So we're going to say 1.4, 0.0.0.3 area 0. That's going to put him in the backbone area, right? Because remember, it's every 4 networks when it's /30, right? So 172, the first block is 172.30.1.0. The next network is 172.30.1.4 is the next network, and then 1.8, so on and so forth. .5 is in the .4 network block, if that makes any sense, right? I hope I'm making sense there. What else we need to do? I think we need to put router 1. We put that one in 1.0. Let's make sure router 1. So this right here needs to be in the 1.4. That needs to be in the 1.4 network. Now that I think about it. So we need 2 network statements for this guy. Let's do that. Let's do that. And if we don't know, that's what I love about Boson NetSim. Y'all know I do my little advertisements for Boson. This is in a let's see. We could check the bottom for the answers, right? So if we go down here, we'll see that what we doing here? What y'all doing to me, man? Okay, I know what's going on here. Interesting. Rather interesting. All right. Let's see. 1.1, 1.5. No, that's the pings that they did. And then they said 1.4. See there? Yeah. So we needed 2 network statements. I was correct in saying that. I'm glad I did that. I'm glad I checked that. I ain't got no shame in my game to check for them answers too. You know, it's kind of like looking at the back of the book for the answers like we did in high school, right? Wow. I know what's going on here. And I'll let y'all know in a second. I don't know if y'all can hear those bings or not. Router 2. Okay, so we did the network statements for those guys. 3. The following interfaces should be configured to run Ospf in area 1. So we need some network statements for router 1's these 2 serial interfaces. So these are sub interfaces, and they need to be in area 1. And then router 2's interfaces. So we go to router 2, who is back over here. He's got a fast Ethernet interface, bloop, right here, and a serial interface right there. That needs to be in area 1. What else we got there? Router 2's serial 00 NFA10, that's this guy right here. And then router 4 is serial 00 NFA00. So this right here is in area 1. This right here is in area 1. So area 1, area 1, area 1, and area 1. What else we need? And then he said router 1's sub interfaces. So we got router 1 over here. This guy right here has got some sub interfaces. That's also going to be part of area 1. Right? We got area 1 over here. And then we got the backbone right over here. That's why they named these BB router 1 and BB router 2. Right? So that's what we're going to do with those guys right there. You guys coming back? What y'all doing? What y'all doing, man? We got the whole damn thing going down here. Okay, I think I see what's going on, but we'll see. Okay. The following info. Okay, so what else we got? Out of 4. So we need some network statements. They want us to put some network statements so basically the same thing we did up here. They want some network statements for those guys right there. On router 1, what network statements are we going to use for those sub interfaces? Notice show protocols doesn't give you the IP addressing for the sub interfaces. That's one thing I just learned about this right here. So we actually have to do show IP interface brief. But I don't like show IP interface brief there because they don't give you this remember, they don't give you subnet mask. So show if we do exclude unassigned like that, it gives us the IP addressing, but it doesn't give us the subnet mask. Now I'm gonna guess that these are point-to-point networks and they're probably /30. So I'm gonna guess that this is in the 10 network. That's probably 10.4, and this is probably 10.8 network just by looking at this, right? We can verify that with what? Show. What's a good way to see all of them? We could just do show interface serial 0/2.1. That lets us know it's a /30. So for that guy, we can do the 10 network 0003, believe, for that one. My goodness. Boy, oh boy, oh boy, oh boy. I think I see what's going on though. Let's see. So yeah, router 1, we'll do a network statement that catches that, which will be 10.0.0.0. What subnet mask? 0003 should be good for that one. And then he said that's going to be in area 1, I believe. Yes, area 1, right? And remember, we just planning this stuff right now. We'll do the configuring on right here, task 3, configure and verify multi-area Ospf. So right now we're just doing the planning part. So the next subnet, we need the subnet mask for this guy and this guy just to verify, right? So 2.2 like that. He is 10.0.0.5 or 0.005/30. So in this case, a network statement is going to catch that is probably 10.0.0.4. Boy, stop blowing up over here, boy. Okay, 10.0.0.4/30. So in this case, 10.0.0.4, 0003, area 1 is what he said. Oh, goodness. All right, security. Don't worry. Be happy. 0.0.0.4. Okay. Now, next one. What's the next one we're going to do? 2.3. So 2.3. Next one should be, this one is in the 10.0.0.8 network /30. So in this case, 10.0.0.8, 0003. That's also area 1, right? Here's what we're doing right here. The sub interfaces there are going to be in area 1, right? Because this is area 1 right here. This is area 0 right here, right? And we're probably going to put, I don't know, I guess this is going to be an area area 2 over here. Not sure. I haven't done that part yet. That should catch those network statements on router 1. What else do we need? Let's see. Backbone router 1. Come on, buddy. I'll let y'all know what's going on over here. I keep looking over to the side for. So we got router 1, router 2. We need a network statement that's going to catch those. All right, so we did that. Now we need some network statements on router 2s for router 2. So we got those guys right over there. I'm going to put router 2, so R2. The network statement that's going to catch 000 and FA10. So for router 2, we need a network statement for this and a network statement for that. Right, so let's go to router 2. Where's router 2 at? Router 2 is right over here. And let's take a look at his interfaces. Come on, buddy. Show. Let me see what y'all saying. I'm sorry, I haven't even seen y'all over there. Oh, he said, yeah, SIM hacking is real. Let me refresh real quick. Yeah, it is, man. Yeah, it's just crazy what happened with T-Mobile over there. My goodness, boy. I'll let y'all know what's going on here with this. in a second. All right. Yes, admissions. Let's see. Let's do a show protocols. See what his network or what networks these guys are in. We have this guy that sits in the 10. That's pretty much the 10 network. So we need a network statement for the serial interfaces, which is over here. That right there. I think the 10.0.0.3 should work for that guy. So for router 2, we should say 10.0.0.0 0.0.3 area 1. Oops, area. So pretty much the network, same network statement as this guy right here. Bloop, right there. Area, that's going to be in area 1. And then the FA10 interface, this is right here. Can y'all hear that beeping over there? Y'all let me know if y'all can hear that beeping. Anyway, 10.3.0 network. I say 10.3.0. 10.3.0.0 should be for that guy. That's router 2. So we'll say the 10.3.0.0 0.0.255. That should also be in area 1. That should be a good network statement for him. Right? We got 2 network statements, one for this guy, one for that guy. Now I think we need to go to this router right here, router 4, and do some network statements for this interface and that interface. So router 4, which is down here. Scroll down there. We haven't touched him in a while. Let me see. Enable show protocols. And we need something for serial 00, because that's what they said, right? On this one right here, router 4's 000 and FA10 interface, right? Here, I'll show you, just in case you lost, right? This is the router 4. Let me erase all of this right here. He said we need a network statement for the 000, so this is the serial interface, right? As indicated with this lightning bolt. And the FA Fast Ethernet 10 interface, which there's only one more interface here, and that's right there. So we need an interface that's going to put this in Ospf and this to participate in Ospf. So we're going to need a good network statement for that. In this case, it is the 000 is in the 10.0.0.4 network, right? Y'all see why? Because this is /30, and .6 is in the 10.0.0.4 network, right? We got to know our subnetting for this one, right? So for router R, we need network statements for R4. This is the 10.0.0.4 0.0.0.3. And we said we're going to put that also in area 1. And we need another network statement for this right here, which is the 10.3.0, which should be this one right here. Same thing as that one. That one right there. That should also put that one in area 1. My goodness. Okay. So where are we at here? Y'all with me so far? Let me know if you got any questions or if I'm confusing y'all or whatever. Shout out to everybody in the chat. Y'all make sure y'all hit that like button. Got S Smooth in the building, Professor Black Ops. Here's your 2 cents, Foster, Peter Hunt. So appreciate all you guys for tuning in and stuff. Y'all know like I said, make sure you join the Discord server. I might change my streams to 9 o'clock because 9 o'clock seems to be a much more ideal time for me to stream. So router. So we got some network statements for area 1 with these right here. They asked us to write them down right here, which we've done already in this little notepad right here. The following interfaces should be configured to run OSPF in area 2. So router 1's 0.0.2.3 network and then router 3. So this is going to be area 3, I guess. We got a sub interface over here, and then this right here, I guess you could say that's area 3. So this is area 3. This over here is area 2, and this right here is area, you guessed it, I'm sorry. Did I say 3? That's area 2. So this actually supposed to be area, my bad. So that's area 2, this area 1, and this area 0. So 0, 1, and 2. My bad about that. So we need another network statement for router 1 for the serial interface. Serial 2.3. 2.3. What is that? So go back to router 1, right? And show interface serial 2.3. What's going on here? What did I put? What did I mess up? Show interface serial 0/2 0/2.3. There it is right there. So this falls in the 10.0.0.8 network. Do we have that in here for router 1? We do. That network statement should, oh, wait a minute. That's wrong. That's weird. Oh, we already put this. That's why. We already put a network statement in there for that. So I was thinking ahead of myself when I put that interface, when I did it earlier. I hope you guys caught that, right? So we need another network statement that's going to put router 3's serial and fast Ethernet interface. So we need we need to put this in area 2 and that in area 2, right? So we'll put another one for router 3. We'll say R3 like that. Come on, buddy. We got some shit going down. I'll let y'all know in a second, man. It's crazy. Let's see. It's 20 minutes, man. Let's see. Let me see what's going on. 22. Q. 60. That's 35. Damn. WC. Okay. All right. Where were we at here? We said router 3. We need some network statements for router 3. So let's go back to router 3, which is over here. See what interfaces he got. Enable, show IP interface brief. And this doesn't show us the subnet mask, so I like show protocols. Damn. Killing me, man. Anyway, we need a network statement for this right here. What network is that? That is the 10.0.0.8 network. So for router 3, we need something for the 10.0.0.8 network. 0003, right? Wildcard mask for /30. And then we need to put those in area 2. And then this last one right here, which is the fast Ethernet interface, which is that right there. That's indicated by this little red line right there. That interface will be a network statement that'll catch it will be 10.5.0.0. Right, so we should use the 10.5.0.0 like that. And then subnet mask of 000. We don't care about the first 3 octets, but that last octet, 255. I mean, we care about those first 3, but that last one we don't care. So, and that's going to be in area 2. So I think that should be all of our network statements right over here. Y'all let me know if y'all have any questions or if I threw you off or anything like that. Now, again, this is just the planning stage. We're going to start doing the configuring here in just a second. What else did they say here? So those should be in area 2. Use the following and then write them down they want us to do here. And then list the Ospf network statements necessary to accomplish the configuration requirements in steps 2 through 4. You will implement these in the following task. So these are it right there. They asked for it here, but I just wrote them down in this little notepad right here. These are going to be all of our network statements, basically. So for backbone router 1, backbone router 2, router 1, 2, 3, and 4. And there's my network statements. Router 1, 2, 3, 4, and then backbone 1 and backbone router 2. Those are the network statements we need to use. What command displays whether a router is an ABR? I think it's show IP OSPF border routers. Let's see. Y'all let me know. Do y'all know? Do y'all know? Let me know. We got Helmet Chili Gaming in the building. Appreciate you for tuning in. Peace, peace. Do you know a command that's gonna that displays whether a router is an area border router or not? And I believe it's show IP OSPF border routers. Let's just see. Y'all hit me in the chat if y'all know the answer to that one. I think it's show IP. Well, let's look at this. Let's look at this. We have all these circles right here. Who's going to be an area border router? So somebody that's going to be in two borders. Most likely is going to be this guy right here, router 1. Because why? Because he sits in between area 0. He also has sub interfaces in area 1 as well as area 2. So he should really be an area border router. That guy right there. I don't think anybody else is in here. So let's go to router 1 and see. Well, we didn't even configure OSPF yet, so that's not even telling us. But let's just see. Show IP OSPF. Is it border routers? No. What is it? Show IP OSPF neighbor? No. There's definitely a command that lets you know. That lets you know who is an ABR or not. Oh, is it just show IP OSPF? I think it's just show IP OSPF. We'll see. I think we'll see. We'll see after that. What command displays a router's OSPF adjacencies? That should be easy. Show IP OSPF neighbor should tell us our adjacencies. What command displays the link state data? I believe it is show IP OSPF database. That should give us information on the LSAs. What command hang on for just a second, y'all. Y'all give me a second. Y'all give me a second. Okay. Where was I? What command displays whether the link state information that was learned was correctly added to the IP routing table? What command displays whether the link state information that was learned was correctly added to the IP routing table? I really don't know that one. Displays whether the link state information that was learned was correctly added. I guess just show IP route, right? If you do show IP route, it'll tell you all the OSPF routes that were learned, and it adds it to the routing table. So all the best OSPF routes will be added there. And whether the link state information that was learned is correctly added. Yeah, it should be show IP route should tell us that one. But let's just see. Task 3, question 9. That's what I love about this application. Yes, right there, show IP route. Well, I was correct in that. And then show IP database was correct with the link state database one. Show IP OSPF neighbor was correct. So I was writing all of them. Show IP OSPF tells us where it's an ABR or not. Good. I'm glad we got that correct. All right. So where were we? So those were the basic show commands. Now what we came to do, configure and verify multi-area OSPF. This task involves implementing and verifying configuration planned in task 2 on all 6 routers. Configure each area in area 0 with a Loopback 0 interface. Use the following IP addresses and subnet masks. So these guys right here, and this is what Foster was asking about earlier. So we haven't created router IDs just yet because they wanted specific router IDs, but learned configured automatically through the loopback address. So let's go ahead and give a loopback to backbone router 1. So let me show you real quick. This area 0 right here, right? Also known as the backbone area. this right here. Bloop. This is area 0, right? They want us to give this guy backbone router 1 as the his loopback is going to be 11, 11.11. I'm not going to write a whole bunch of 11s, but he's 11, right? And then backbone router 2 is going to be 22, 22.2. Shout out to Jay-Z right there, right? 22 for backbone router 2. And then router 1 is going to be quad 1. So 1.1.1.1.1.1. So 1.1.1.1. So that's going to be his router ID, right? And he's 22. He's 22.22.22. And you know what I mean with that, right? So, and let's go ahead and do that. So let's go to router 1, global config mode, and he's going to be interface loopback 0. IP address is going to be 1.1.1.1. And then the Subnet Mask is 255.255.255.0. And then let's verify that. Show IP interface brief. Do I have my loopback brief? My loopback is right here. Boop. He's good to go. He's good to go. Good to go. And then backbone router 2. Let's give him the 22. Let's go to router 1. Router 1 is 11.11. So global config mode, interface loopback 0. His IP address is 11.11.11.11, and then /24. So 255.255.255.0. What else? Backbone router 2 is 22, right? So we go to backbone router 2. Global config mode, IP address or interface loopback 0. IP address is 22. 22.22 fingers, man. 22.22 /24 255.0, just like that right there. We'll do let's just verify our work with show IP interface brief. And there's my loopback. So now, once we turn on Ospf, he's going to pick the highest loopback address, right, to be his router ID for all of them, right? Because otherwise, if we didn't do this, if we just turned on Ospf with all these network statements that we did here, he's going to pick the highest serial interface because the loopback wasn't configured just yet. And then we would have to clear the IP Ospf process for that to take effect. So we got to be careful with that. Step 2. How many questions? How many steps we got for this one? This is task 3, step number 2. My goodness, bruh. Where were we? We said, okay, yeah, so task 3, I want to see how many steps there are in here. Task 3, Jesus Christ, 24. All right, so we're on task 3, step number 2. Configure each router in area 0 with specific network statements so that following interfaces run and advertise Ospf area 0 networks. Use 1 as the Ospf process ID. Backbone router 1, serial. Look at this, man. This is all jacked up here. What's going on here? Is it because like what's going on here? I gotta zoom in or what? Y'all see this right here? This don't look right. Backbone router 1, serial. What? What's going on with these people at Boson, man? I'm sitting here trying to advertise their stuff and promote their application, but they got shit like this in the application. But whatever. Let's go to backbone router 1, and I guess we just need to do our network statements, right? So this right here needs to be in area 0. Process ID 1. So we'll go to backbone router 1. Exit out of that. Router Ospf 1. Do me like that, man. Come on, man. Come on, man. Come on, Vlad. Damn. Killing me with this one. All right. All right. So we need a network statement that's going to put that right there. Let's go ahead and copy and paste that bad boy. In area 0 is what they said, right? Process ID 1. So router Ospf 1, network. Can you copy and paste with Boson NetSim? Yes, you can. Good to go. All right. And we said we're going to put that in area 0, right? So we went to backbone router 1, and I'll show y'all real quick, right? We went to backbone router 1, this guy right here, and put this interface in area 0, right? Area 0. That's an ugly ass 0 right there. We got to do the same thing with, I guess that's going to be backbone router 2, however they wrote it over here, and then this is probably going to be router 1, and they want us to put those, basically put those network statements that we planned earlier. So we did backbone router 1. Let's go ahead and backbone router 2 and put that in area 0, right? So go to backbone router 2, which is that guy right there. Bloop, bloop. And he said global config mode router Ospf 1. And then the network statement we're going to use is this right here. Come on, man. Come on. Let me make sure I put the correct one. Yep, 1.4 is going to be in area 0. And then on router 1, we need to do the serial 00 and 01 interface to put those in area 0. So router 1's network statements that we came up with earlier for this for the area 0 should be these guys right here. So let's go to router 1, right? Here, I'll show y'all real quick. We're going to go to router 1 and put this interface in area 0, that interface in area 0. Not this one yet, right? Because this one is going to be in this one has sub interfaces that's going to be in area 2 and area 1. So we ain't fucking with this one just yet. We're just going to mess with this one right here and this one right here, right? So let's go back to router 1 and go to global config mode, router Ospf 1. The first network statement that we wanted for router 1 that we said earlier was this right here. And judging by this, we should be able to have 2 neighbors, right? Once we do this, right? We should have a neighbor coming this way and a neighbor coming this way, right? Or this way. So let's put that network statement. First network statement should give us a neighbor. Bloop, bloop. Did I copy it yet? I guess not. Copy. Oh my God, this is my mouse, man. My mouse is terrible. If you want to donate to your boy, I got a new phone finally, man. That network statement should at least give us a neighbor, the first neighbor. We should see a syslog message letting us know we have an Ospf neighbor coming up. Wait for it, wait for it. Watch these. 172. While that's going, let's go. Let's get the other network statement going, which is the 172.13.30.1.4. There it is right there. So now we got a neighbor. Who is that? 11.11.11. Who is that? That is this guy right here. So now them 2 guys became neighbors. These guys right here became neighbors. One more network statement should make them 2 right there become neighbors, right? So that's that second network statement, which is this right here. Oh man, this damn mouse, man. Control C, man. All right. Network that, and that should put them 2 to become neighbors. Wait for it, wait for it. Get on our knees, pray to the network gods. That's not good. All right. I have some stuff to do that I'm after this stream here. Come on, buddy. There you go, right there. Ospf adjacency, process ID 1. We got the neighbor is 22, 22, 22, 22. Who is that? That is this guy right here. So good to go. We got 2 neighbors. That's exactly what we was looking for. On all 3 routers, verify that the Loopback 0 interface IP address was selected as the router ID. So they want us to verify the router IDs for these guys right here. The router ID for this guy, and this guy. What command we say we do that with? Show IP Ospf, right? That lets us know the router ID. Show IP Ospf. What's his router ID? 1.1.1, right? For the loopback. Remember, if it picks the highest loopback IP address, if that's not available, then it picks the highest up physical interface's IP address. So that's why he picked that, because that's the loopback address. We got to do backbone router 1 is over here. Show IP Ospf. What's his? 11.11. Good to go. Next guy was backbone router 2, which is up here. Show IP OSPF. He should be 2222. Good to go. 22 twos. How many network type 2 LSAs should exist in an LSA database for area 0? I want to say it should be 3 type 2 LSAs. Because the network LSA lets us know how many neighbors we have in our area, I think. So it should be 3 type 2 LSAs, I think. Let's see. Y'all know I haven't memorized the LSA types yet, so don't judge me. Show IP OSPF database should let us know, and I was correct. We got 1, 2, 3 LSAs. No, that's a type 1 LSA. Let me see. This is a type 1 LSA. That's wrong. That's wrong. Network LSAs is what they wanted. Type 2. So we got none. None so far. So what I was talking about was type 1 LSA. We'll have 3 type 1 LSAs. How about the other guy? Let's see. If we check another guy. Is he going to have just type 1 LSA and that's it? Show IP OSPF database. Yeah, he's only got a type 1 LSA, which is the router LSA. And there's 3 of them. So the answer was 0 for that one. I was wrong on that one. For this one. Type 2 LSAs. On backbone router 1, verify your answer to the previous step, which I did already on, yeah, there it is right there. But to verify our answer, let's check. Task 3, question 4. Task 3, question 4. No type 2 LSAs should exist in the LSA database for area 0 because all links in area 0 are serial point-to-point connections. So I was wrong with that one. Y'all see that? Ain't no shame in my game. I have yet to memorize those LSAs, man. There's 11 of them, and for the CCNP, we got to know, like, I think just 7 of them, but still, man, I have yet to memorize those things, man. I made some flashcards. I have yet to memorize them, but it is what it is. What's the next one? Next question. On backbone router 1, no, we did that. On backbone router 1, examine the OSPF link state database and compare it against the IP routing table to verify that the correct information was entered into its routing table. How do we check the link state database? Is it just show IP OSPF database? Or, let's see, he said on backbone router 1, so show IP OSPF, what is it? The link state database. Yes, it is database. Compare it to the IP routing table to verify that the correct information was entered into the routing table. So we do show IP OSPF database. These are the advertising routers. If we do a show IP OSPF, I'm sorry, show IP route for the routing table, right? To see the routing table, we have stuff from the 11 network. Why do I not have anything from the 22? I should have seen something in here, shouldn't I? Is it because we don't have anything for the 22 network? We got something. That's weird. I guess that's correct, but I see something from the 11 network. I just don't see anything from the 22 network. That's learned through OSPF. I don't know. Who knows? I'll skip that one. We'll go back to that one in a little bit. From backbone router 1, ping backbone router 2's 000 interface. The ping should be successful. So from backbone router 1 to backbone router 2. So backbone router 1 to backbone router 2. So we're going to ping from here to there, and it should be successful. What's the IP address? 172.30.1.5. So ping 172.30.1.5. We got a reply. Good to go. Good to go. On router 2, router 3, and router 4, configure a loopback 0 interface. The IP address of each interface should follow the pattern XXXXX, where X is the router's number. For example, router 2 is 2.2.2. Blah, 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 blah. All right, fine. So router 2, 3, and 4. So he's going to be, his ID is, or his loopback is 2.2. He'll be 4.4, and he'll be 3.3. And use the subnet mask of /24 or 255.255.255.0. So we'll go to router 2, give him the loopback interface, configure terminal interface loopback 0. His IP address is 2.2.2.2. They said /24 subnet mask .0. And then we'll go to router. Is that router 4 over here? No, that's router 3 over here. Same thing. We'll give them 3s. Interface loopback 0. IP address is 3.3.3.3. 255.255.255.0. What else we wanted to do here? Router 4. We'll go to global config mode. Interface loopback 0. His IP address is 4.4.4.4. 255.255. 255.0. No shut. Well, I don't need no shut. It's already going to come up. But y'all know on a real router, you'll see a little, you should get a little syslog message let you know that the loopback is up. But we configured the loopbacks. Let's just verify our work with show IP interface brief. He is 4.4. He should be 3.3. Show IP interface brief. He's 3. And then 2 should be 2, right? Let me move that guy over. 2. Wake up, Mr. West. Show IP interface brief. And he's 2.2. He's up, good to go. Configure each router in area 1 with specific network statements so that only the IP subnets on router 1's serial 2.1 and serial 2.02.2 interfaces, router 2's 0.0.0, blah, 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 run and advertise in Ospf area 1 networks. Use 1 as a process ID. So basically, we're going to do all of the network statements that we came up with for each router, respective router, but for area 1, right? Here, I'll show y'all real quick. Where's my fancy schmancy diagram right here? Microsoft Paint. Y'all know I don't be using Visio or any of those other. I've been using Paint since like the freaking 7th grade and shit. So I'm so comfortable using it. I know the shortcuts and everything. We need to put. Where is it? Let me use this one. This in area 1, that in area 1, this in area 1, this in area 1, this in area 1, and then we have some sub interfaces that's going to put that in area 1 and that in area 1, right? We're going to put another one over here in area 2. So we're just going to have some 2 interfaces that's going to point that way and that way to area 1, right? Remember, this is area 1 right over here. That's area 1. This right here is going to be area 2, right? That interface and the little sub interface right there. That's going to be area 2, 1. We already did area 0 over here, so we done there. So let's go to what they said on router 1. Let's put these network statements right over here that we came up with earlier. Router 1. Y'all with me so far? Y'all any questions or anything? Thermal Cowboy said, dang, I've got so much to learn. Hey, we all do, man. We all do. We got Kelvin in the building. Appreciate you for tuning in. He said, more Cisco. Yep, more Cisco. And y'all know I'm going to have to pretty much learn some. I'm going to have to learn some Palo Alto. I might do some Palo Alto firewall stuff on this channel pretty soon because got some stuff at work that you'll be working with, some firewalls at work. So I really got to learn some more of that, even though I've been trying to I've been focusing on CCNP stuff. It's just, you know, a lot of this stuff, like I don't deal with OSPF at work. So, you know, this is just like stuff I'm doing on my own time right here. It's kind of difficult to study for stuff you're going to, you know, to do on an exam versus what you actually do at work. You know what I mean? So it's just a lot going on my plate. That's why I've been canceling a lot of streams and stuff like that. So plus, you know, just life happens. Anyway, Jesus. Dang, what's going on here? Okay. I see you with that one. Let me make sure of something real quick, y'all. Real quick. Need to check something out. That's the lab. And then that one was set to, I don't even know. Whatever. Okay. Where were we? Router we was going to put these guys in area 1. So we're going to go to router 1. Bloop. Here's router 1. And do those network statements. We'll go to global config mode. We say router OSPF 1. They said process ID 1, right? Didn't they? And then, yes, right there, it says right there, use 1 as the OSPF process ID. And then do our network statements, which is the ones we planned out earlier. So let me make sure this floats. Is there a way I could keep this up top? Whatever. Let's move this over so we can see all of them all together. Now let me know if any of that stuff is in the way or what. Network statements. So we got the 10.0 network like that. Yeah, with that, man. Shout out to Darius M, Red Pill channel. 0003 area 1, and that should put what interface into OSPF? Let's see. Let me see what those interfaces were. That should put this sub interface in area 1. But that last one needs to actually be, I believe, in area 2. I believe this need to be in area 2. Yeah, I just now caught that. Just caught that. And then, yeah, because those guys are going to be in area 2 right over there. Just caught that. Yep. 10.3. Yep. I hope y'all see what I just caught right there. Let me know if you have any questions. But so we need a network statement that's going to put that one right there. I think that should be a 10.000, the 10.333, the 0.000, and then 0.003 area 1. So them two in area 1, and that last one should be in area 2. So let's make sure we do that correctly. The next network statement should be what we just wrote right there. 10.0.0.4 0.003 area should be in area 1. Right? And then they want us to do router 2 and router 4's network statements. So router 2 and router 4, those guys are in area 1 as indicated by these network statements, right? So we go to router 2 and do the same thing. Global config mode, router OSPF 1, network 10.0.0.0, 0.003 area 1, and that last one should be network 10.3.0.0, 0.0.255 area 1. That should give us a neighbor. I think that should give us a neighbor between router 1 and router 2, I believe, if I'm not mistaken. With my love. So now that we put that network statement, we should have them two right there. We did it on router 1 and router 2, I believe. Yeah, so that should theoretically make them two guys right there become OSPF adjacent with each other. We got underneath right in the network guys, and there it is right there. We got a little message right there. Who is that? 1.1.1. That's this guy right here. And he said his neighbor is 2.2.2. So, yep, them two became neighbors with them network statements. Good to go. Good to go. What's the next one? We need to do same thing with router 4 and put them in area 1. So once we do the same thing, we'll do the same thing with router 4. We'll put that interface and that interface to participate in area 1, and that'll make them two become neighbors like this. And then it should give him a neighbor with this guy right here. He'll become a neighbor with router 1 like that. But then if you notice, he should theoretically, I think he should have 2 ways to get to router 2 once he do that. He'll have I think it'll show like he's got 3 neighbors. We'll see. We'll run that OSPF command, the show command, to see how his neighbors look like. Go to router 4, put the network statements that we came up with earlier. Go to global config mode. We say router OSPF 1. So I was getting too giddy about them network statements. Network 10.0.0.4, 0.0.0.3 area area 1. And then one more network statement should put the other guy as a neighbor. Network. Am I correct in doing that? Router 4, right? Oh, yeah, because I'm just not started. I was like, what? I thought I did that already. So 10.3.0.0 0.0.255 area 1. We got a neighbor already. 1.1.1. So them two became neighbors like this. Them two right there. Them two right over here became neighbors. And I think this next network statement makes the other two become neighbors via fast Ethernet 0.1.0. So now them two became neighbors going this way, right? Via the fast Ethernet interface. So we're good to go there. And lastly, we have to put some network statements, I believe, in what's that? Router 3, this guy right here. We need a network statement that's going to put that in OSPF and this in OSPF. And the network statements we came up with router 3 is that one right there. That's area 2, basically. Just going to put all this in area 2. So actually, that interface right there. So that'll make this right here area 2, right? So let's go to router. What router is that? Router 3 down here. We hanging out down there at the bottom. I'm going to go to global config mode router OSPF 1, and we use that network statement that we came up with earlier, which is 10.0.0.8 area 2, area 52. What am I doing there? What did I do wrong, y'all? What did I do wrong? Network. Oh, I need to come up with the wildcard mask. What am I thinking? 0.0.0.3 and then area 2. And then one more network statement that we came up with earlier, which was 10.5.0.0, 0.0.255 area 2. And we should have, how many neighbors should we come up with that? We should just have one neighbor with this network statement. But he's also advertising. He used this one to advertise the 10.5.0 network. That's what that is. Get underneath, pray to network gods. We'll just wait here. Don't worry, I'll wait. Y'all any questions so far? Y'all hit me that like button. Make sure you subscribe. Typically, I stream Monday through Thursday, 8 p.m. Eastern Standard Time. But I'm gonna be changing I think I'm gonna be streaming at 9 o'clock now because this is a more ideal time for me, man. Gives me time to at least relax from work or eat, stuff like that. So where we at? Jesus. Come on, man. We put that network statement in router 3, didn't we? They don't look like, oh, you know what? Did I put the right network statement? Yes, I did. So why it don't look like they're waking up there? Did we just get a message? No, we didn't. That don't look good so far. I don't see nothing just yet. We should have got a message just like we did on this right here. These little OSPF adjacency areas. So it's possible that we got some not good network statements. Let's see. So run section OSPF. What did we use? We use 10.0.0.8 0.0.0.3 area 2 and 10.5.0.0. They look good to me. Let's do a show IP interface brief, and let's see what we got there. We said the 10.0.0.0. Did we use 10.0.0.8? We did. So that's the 10.0.0.8 network. That should have caught the serial interface. And then 10.5.0.0 0.0.255. That sounded right. That looked right to me. Y'all like these network statements or nah? Because they I don't think I got an adjacency with those. Show IPS neighbor. Nope, I don't. Show IP OSPF. We have the routing. It says no. There's two interfaces in that area. area 2. Maybe I did not put that last statement in area 2 for router 1. That one is probably what it is. Let's go to router 1 and see. Did we put that interface in area 2? Let's see. 2.3 don't look like it came up. So let's look at show run section Ospf. That's what the problem is. Y'all see that? This last, we didn't put that last network statement in area 2. So that's what we're missing. Glad we caught that. So go to global config mode. We say router Ospf 1. And we say network 10.0.0.8 0003 area 2. Get on our knees, pray to the network gods. Are we going to get a neighbor now? Right, 10.0.0.8? Yeah, that's the 10.0.0.8 network for sure. Because he was .10, and then the other one, our prayers are not being answered by the network god. Yes, they are. There they go right there. We got an adjacency. Hallelujah. Y'all see that? So we was missing this network statement right here. That was going to catch this interface and a network statement. We had our network statements for these guys right here, but I forgot to put this one right here. Probably because I realized it was in the wrong network. I mean, in the wrong area. And, or maybe I just said I was going to come back and do it later. I can't even remember, but for some reason, we left that out. And that's why they didn't become neighbors. So good troubleshooting that we did right there. So now we got a neighbor, and that made that put this guy and this guy and this guy in area 2, just like we planned. What else we got? On router 1, verify that the 0, 2, 1 are configured to run Ospf in area 1, which we pretty much did with the show command, but we'll do it anyway. Let's go to router 1 and then show. Y'all hit that like button. Make sure you subscribe to your boy Ospf. Just Ospf. That'll let us know 2.1 and 2.2 is in area 1, right? How we do that? We do show IP Ospf. We'll see right there. It says number of interfaces in this area 2. They're in area 1. What are those interfaces though? The way we do that, that lets us know that there's 2 interfaces in this area. But what interfaces are they? Now we can do a show run and then section Ospf. That'll tell us, but interface. That's how we do it. Show IP Ospf interface serial, and then they said what interface they want us to check. 2.1 and 2.2. So 0/2.1. That lets us know it's in area right there, area 1. And we do the same thing, but do a 2.2, and that lets us know it's in area 1 as well. So the interface command is what do it. Show IP Ospf interface, and then whatever interface it is, and then that tells you exactly what area it's participating in. So we did that right there. On router 1, verify that the adjacencies have been established with router 2 and router 4 in area 1. So they want us to verify the area 1 interface, area 1 routers, right? So he said router. What did he say? Routers. I'll show y'all real quick. The adjacencies between router 2 and router 4. So they want us to see that this guy and this guy are configured to be neighbors with this guy in area 1. How we do that? Show IP Ospf neighbor. Show IP Ospf neighbor. Right? No, this don't tell us the areas. This tells us who's our neighbor, but this don't give us area information. On router 1, verify that the adjacencies have been established with router 2 and router 4. Well, this lets us know that router 2 and router 4, because we made those loopback interfaces to align with the router numbers. So this kind of lets us know that we made some adjacencies with that. What else could we do here? He said, stop relying on the thinking of I messed up the network statements. That entirely ignores the possibility that there's something operationally wrong with OSPF. Use your debugs. Debug IP OSPF adjacencies. Show commands, e.g. show IP interface brief, blah, blah, blah. It'll work for you more consistently often. These tools exist for a reason. Use them. Yes, I should. You're right about that. You're right about that. I guess sometimes I have a tendency to kind of just rely on the configuration and stuff like that. I could have done that as well, but I know that we know that all we touched was the network statement. So yeah, you're right about that. We could have used some other network statements to see that we were missing something. So I could have used some other show commands to see that issue. What else? Good point though. Good point. Good tip. Router 1, verify that it is stability. Oh, we did that already. How many network LSAs should exist in the LSA database for Area 1? That's a good question. Type 2 LSAs. So we know there was no Type 2 LSAs in Area 0. They want to know how many should exist for Area 1. That's a good question. Well, we know that there's 3 areas altogether. We got Area 0, Area 1, and Area 2. What is going on? Oh, okay. Whew. All right. I'm gonna give you a little something of what's going on over here, but I'll tell y'all in a second what happened there. But what else we need? They said verify. Oh yeah, we want to know how many network LSAs we got. So let's just do a show IP OSPF database. Let's see how many we got. We got. This is a summary net link. This is a type router link. That's a type 1, right? And then this is a net link router link. That's a type. No, that's type 1. This type 2. And let's start from the top. Type 1. Summary net link is what? Type. Anybody remember? Is that type 3? Can't remember. That's for Area 0. This is type 1 for Area 1. Type 2 for Area 1. Net link. So it should be net link. It looks like for this one right here. That's probably the one that we were looking for. That's a type 2 LSA. And they asked how many type 2 LSA should exist in the LSA database for Area 1. And it looks like it's just 1, but let's verify that answer because y'all know I've yet to do those, memorize those LSAs. Task 3, question 12. Task 3, question 12 was, yes, 1 network type 2 LSA for the 1030 sub should exist in the LSA database. So yeah, it was just one network LSA. So we was right in verifying that, but I didn't even take a guess. So on router 2, verify your. We did that already. 14. We'll have like I think 24 questions right there. So we're at 14 out of 24. Configure OSPF to run and advertise only the subnets. Wow. Okay. Didn't we do this already? Thought we did this already. No, I guess not. Configure OSPF to run and advertise only the IP subnets in Area 2 on router 1's serial 2.3 interface and fast Ethernet. And router 3's serial 0.0 interface. Use 1 as the process ID. Did we not do this already? I guess we did. Yeah, we kind of did this already. I guess I was just kind of ahead of time. They wanted us to I don't know. Yeah, I guess I kind of did all the configuration already. That's what happened there. I was ahead of myself right there. List the ABRs in the network. I want to say router 1 is the only ABR, if I'm not mistaken, because he's the only one that sits between a whole bunch of areas. Right? Because let's look at the map here. Let's look at the map here. If we just kind of draw out the topology for the areas, this is area 0 right over here, also known as the backbone router. I mean, backbone area, area 0. We got area 1 over here, which the layer 3, layer 2 switch does not count, right? This should be area 1. And then this is area 2 right over that interface right there, kind of falls under all of them. So this is area 2 over here. That's area 2. So the only guy that sits between all these areas is this guy right here. So he should be the area border router. Let's go to question number 17 to see if that's the answer. Just using my that's how I'm looking at it. What he said, question number 17. Yes, router 1 is the only ABR in this network. Okay, good. So that's what I thought. That was 17. 18, we got 18 out of 24. We're almost done here. Observe the OSPF process information on each ABR to verify your answer. Well, I just kind of drew all this topology with my special Microsoft Paint to kind of determine that answer. So no, I'm not going to do all of that. What information indicates that the router is an ABR? Well, let's do a show command real quick to verify that too. We could just do show IP, what is it? I believe OSPF to kind of verify that, right? Gets us low. We got area 2, area 2, area 2. No, that don't let us know. That don't let us know. I forgot what command lets you know whether somebody is an ABR or not. It's not database. It's not database. Y'all remember the command that lets you know? It's not network. It's not neighbor. It's not database. It might be interface. Or would we just do the process ID? 1 like that? Nope, that ain't gonna tell you either. If you just do, no, that ain't it either. What command lets you know? Because there's a command, I can't remember. It tells you, you'll see it in plain English. It says, router blah, blah, blah is an area border router or something like that. I can't remember which command tells you that. Y'all remember? Pop quiz for the day. Oh, there it is right there. It is an area border router. See there it is. I knew it was OSPF. That is right there. So I am an area border router. That lets me know it is an area border router. And then it is, it's not in a specific area. I mean, it doesn't tell you. It tells you this is area 0. See right there. Look, there's area 0. He's also participating in area 1 and has an interface in area 2. And that lets me know. And then at the top of the OSPF, that lets me know that I am a area border router. So that's how we verify with the show command. Conceptually, what does a router being an ABR mean? Well, like we said, it sits between several areas. He borders several areas, which is router 1. 20. Can an ABR that is not connected to a backbone exist? Can an ABR that is not connected to a backbone exist? Yes, a poorly designed OSPF network. So if you have, let's say, yes, you could. Yes, you can. Let me give y'all an example. Let's say, so we got area 0 here, we got area 1 here, and then we got area 2 right here. Let's say we got a router, I don't know, let's say we got a router 7 sitting right here. He's router 7. And then he sits in area, no, let's not do it that way. Yeah. He sits in area 3, right? So he got an interface in area 3. And then this guy right here is router 4. So he has an interface also in area 3. So he has an interface in area 3, but he also has an interface in area 1 and area 1. Therefore, that will make him an ABR. But is he? Oh, but he's connected to the backbone, so that don't count. I guess not. Let's see. What was I gonna say? Let me read that question again. Let me read that. Can an ABR that is not connected to a backbone exist? Yes, but I just can't explain how it'll exist. Does anybody know? Oh shit, my damn stream messed up. Reload, reload. And what's going on with the admin guy? Where's he at? There he go. You got 180. Let me go back. 180. Oh, hallelujah. And then what about 34? Where's 34 at? 34. At 33. I guess we'll find out in a second. Trying to see. Peter Hunt said, "What about a subinterface from the What about a subinterface from the router in area 0?" You talking about this guy right here, router 1? He has several subinterfaces, but either way, he sits in area 0. He's got a whole bunch of interfaces. He got this in area 0, this in area 0. Their question was, can an ABR that is not connected to the backbone exist? Well, this is the backbone, area 0. Okay, so I was correct in saying that. This guy right here is router 4. He would be considered an ABR because he sits between area 1. That is in area 1. And then this guy would be like, let's say, area 3, right? That interface is also area 1. So therefore he's not connected to the backbone. And he is also an ABR. So yes, that can happen. But this is a poorly designed OSPF network. If that happened, if we designed it this way. So let's just see real quick. Question 20, can an ABR that is connected to the backbone, that is not connected to the backbone, exist? Question 20. So 320. Section 320. So no, they said no. An ABR cannot exist outside of the backbone because all non-backbone areas must connect to the backbone. That's bullshit. I don't like that answer. I think it can exist, but it would be a poorly designed network. Just like I just explained here. So y'all let me know if anybody knows. He said YH. I don't even know what that means. So add a tunnel from the new area. Asking. Oh no. But I'm not gonna like kind of veer off of what they designed this with this topology or whatever. But I see what they're saying there. I still think it can exist. It's just not going to be. It will just be a poorly designed OSPF network because now you got area 3 right here that exists, but it's not directly connected to the backbone. Yet router 4 is an ABR if we designed it this way. So yes, it can happen. It's just that it's just not a good design network. So they kind of threw me off with that question. Whatever. 21. On router 3, examine the OSPF link state database and compare it against the IP routing table to verify that the correct information was put into its routing table. You will use this output to answer the next 2 questions. So we'll look at the link state database on router 3, and then we're going to call it a night with those next 2 questions. We almost done here, y'all. Hit with that like button. Make sure you subscribe. Yeah, I think I might move these streams to 3 o'clock because I feel like I have a lot more time to kind of like prepare and eat and stuff after work and everything like that. So show IP OSPF database. What they want us to see in router 3? They want us to compare it to the routing table and verify the correct information put in the routing table. So we have in router 3, we have a type 1 LSA right there. Then we have the summary netlink, which I believe is what type. I think that's type 3 LSA. I can't remember. Y'all correct me if I'm wrong. I can't remember. Now they want us to look at the routing table, compare it, show IP routes, route. We have some inner area routes. We have some regular OSPF routes. Blah 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 blah. What? Where were the summary type 3? So I was correct. Summary type 3 LSAs originated. They originated from the type 3 LSAs. These right here. They're all from this guy right here. Because remember, summary LSAs come from what? The ABR. So that 1.1.1, who is that? That is this guy right here. This guy. Bloop. Right? Let's get rid of all of this shit. Remember, this guy is 1.1.1. So all the summary LSAs came from him. And they come from the ABR, who does the summarization for these who provides summaries for the networks and stuff. Where we at here? How are summary LSAs identified on the routing table? I believe with the OIAs, if I'm not mistaken. So these right here would be the summary routes, right? I think. If I'm not mistaken, y'all correct me if I'm wrong. OIA is an inter area route, but it's not necessarily a summary route, but whatever. Summary LSAs are identified in the routing table. Router 3, verify connectivity with the 172.30.1.0 network, 1.4 network, blah, 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 by issuing pings to the following interface. So we're going to have router 3 ping all these guys right here. Backbone router 2. So router 3 sits over here. So we're going to have router 3. He's going to ping backbone router 2. So he's going to ping bloop, that guy. And then he's going to ping bloop, that guy. And then he's going to ping router 2. He's going to ping that guy. Router 4, the serial and fast Ethernet. So he wants me to ping router 4 going this way. And he also wants me to ping router 4's other interface, which is over here. We could do a trace route to see if they actually take a different route or whatever. So router 3 will ping those last ones. All pings should be successful. Ping 172.30.1.5. We got a reply. 1.1. We got a reply. Last one is 10.0.0 or 00.2. We got a reply. 06. Got a reply. And 3.04. 3.0.4. We got a reply. Good to go. All pings should be successful. Let's grade the lab and pray to the network gods. We completed the lab successfully. Good to go. I typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. Creed9 said, I agree with you, bro. Hey, I don't know. You correct. I mean, I hope I'm not confused y'all with that, but yeah, I'm glad you agree with me. But like I was saying, their question was, can an ABR that is not connected to the backbone exist? You're right. It wouldn't exist if it's not connected to the backbone. But if you poorly design, like I mentioned, if you poorly design an OSPF network where you have an area that is not directly connected to the backbone, then yes, theoretically you can have an ABR that don't connect to the backbone. So I don't know what they talking about, man. Like, it could exist, but like I said, if it's not designed correctly, it would exist. So, but yeah, to the live stream Monday through Thursday, 8 p.m. Eastern Standard Time. You make sure you subscribe and hit that like button. If I do make some changes to the schedule, I will post it in a Discord server. Like, for example, today, let me give you guys the invite to my Discord server so you'll get if there's any changes to the schedule, right? There is a link to the Discord. So like, for example, today, I would have normally streamed at 8 o'clock, but I streamed at 9 o'clock. 9 o'clock seems to be a more ideal time for me. So maybe I might start changing it to that from now on. What else was I going to say? Once I get to 5,000 subscribers, I will be gifting away a copy of Boson NetSim. Like I mentioned, this copy right here was a free one that they gave me to demonstrate on my channel and stuff like that. Plus, I use it to, basically learn and just use it as content for my channel and stuff like that. So I will be gifting away a copy of that once I reach my goal of 5,000 subscribers. And also, you can do this along with me. So that way you'll be like, hey, NetworkBruh, nah, you messed up on question 5. You need to fix that, man. Because I did it and it's working here. And you ain't got it working. So, if you're doing it along with me, it gives us a better learning environment and stuff like that. And then you can post it in the chat and help me out and help whoever else out is using Boson NetSim. And y'all know I love this application. It's a great app. We don't have to do all the basic homework like changing the host name and do the IP addressing and the design and the network like that. We could just jump into whatever, technology we want to learn. So like, for example, today we wanted to let's view the labs. I don't know where that window is. We want to do some VLSM practice. We can just jump into that. We want to do some VLANs. We can just jump right into that and jump right into the topic that we want to learn. So that's what I love about this application. But anyways, y'all hear me that like button? Make sure you subscribe and tune in. For now, comment, like, subscribe to the